Hello, and welcome to our presentation on our project for our senior design uh, titled Real-Time Object Identification Surveillance. So first, a quick introduction to our team. My name is Miles Golding. My other partners are Krishna and Kale, and together we worked to complete this project. We also worked very closely with Western Environmental Statistics to complete this project. We were working for them. This project was requested by them, and we'll have a little bit more information on them later. So quickly, the problem that we were facing was that West, the company we were working for, uses surveillance footage to gather statistical information about wildlife that they capture. So some of the ways they do that are with a drone that they fly really high up in the air so that they can get very nice surveillance photo of large areas to capture both alive and dead animals on those videos for statistical purposes. One thing about West, they are very they get paid to collect this information, and a statement from their website says that West provides environmental and statistical consulting services and contract research nationally, internationally for industry, government, and private organizations. So obviously this information that they're gathering is very valuable to them, and it's very important that it's accurate. Gathering the image from their drone and from their stationary cameras results in lots of footage and lots of images and lots of storage space on computers to even possess all of that information. And so it's very resource intensive. So a little bit about the how and why of our project. We wanted to focus on reducing the amount of footage that they were both capturing and storing. So one way that we were planning on doing this is originally working with the drone. We were going to have it so that it only saved photos of objects that it recognized through an object model. And so West has expressed the need for a better way to analyze the footage, because currently they were flying their drone and taking the photos and then coming back and having to sort through every single photo to find photos that were valuable to them. So one thing that we worked to do was to reduce that load on both their drones and their stationary cameras by identifying photos before they were even stored, so that we knew what was important and what was not important. So some of the design decisions that we made were, originally we were planning on working with their drone to limit the amount of footage they were gathering. So to emulate their drone and create software for it, we had to create an environment similar to the drone's environment so that we could actually make software that worked correctly and did what we wanted it to with both the photo feed and the piloting controls up while it was flying up in the air. So obviously we had to restructure quite a bit due to COVID-19 and the virus. So we had to basically define the resources that we needed for this project. So originally, while we were working with the drone, due to the virus, we were no longer able to gain access to the drone, and even social distancing, we were no longer able to meet and discuss hardware in person while having it on site. So also building on West's existing project, we decided, instead of creating our own model and our own software to recognize the images, we decided to work with their images and their models, so that we didn't have to come up with that ourselves as we scoped further and further down. And we also wanted to decide to make a software that worked on pre-recorded videos instead of real-time videos, because we no longer had the ability to take live video feeds.
So for our major milestones, initially with the project we had in mind, we had to set up the DJI drone environment. which should mimic the hardware capacity of the drone. We also had problems with contacting West because of scheduling conflicts and other reasons, and establishing solid contact with them took some time. Building APIs, mimicking DJI drones APIs was important to us because we didn't have access to the drone at all. We had one meeting where we did see the drone, but we never had the opportunity to use it or build on it. Building our object recognition model was also priority before our restructuring of the project because we didn't have access to West's object recognition model, which we were planning to use. So after the COVID-19, we, like Miles said, rescoped our project to work off a stationary camera. And for that, we had to create a Python project to break our videos into frames which West's object recognition model could use. We also had to create a bash script to control the flow of inputs and outputs from one script to another and seamlessly run the entire project. We also had to integrate our script with West's object recognition software, so we had a seamless integration between them, and the project did what it intended to do. So for our development environment, we are using primarily Python 3 as our scripting language. We're also using OpenCV, which is a package, Python package we used for splitting our video into individual frames, which we then feed into West's image recognition script. Pillow is another library we're using. It's an imaging library, and it's used to read in JPEGs or PNGs, and it can be used to manipulate, do multiplications and resizing, and then it can also be used to save the images. West has given us remote access to their machine, and it is running Ubuntu Linux, and that's what we've been using to develop our project for our senior design. MXNet is a library West is using to train their neural network model. They're also using it to read in a pre-trained model, which is a params or JSON file, and they're also using it to predict on new images that we feed into the model. Pip3 is a package manager, which we are using to easily install all the packages that I mentioned in this slide. So to compare our projected product in the beginning versus the final product which we have now, like Maya said, we started off with a project where a drone could identify objects in real time and notify the pilot. But now you have pivoted to a project which works off a stationary camera, surveils for birds near windmills. Due to our time constraints, our project presently splits the video into frames, passes each frame to West's object identification model, determines the frame numbers where the bird can be seen, and then stores those frames into a directory.
This project hasn't come without sets of roadblocks and challenges for us to encounter, though. Some of the big ones that we were dealing with early in the project was, once again, a lack of communication between us and West. Trying to get meeting times established, times for us to go and use the hardware, run tests, and work on things were quite hard to come by until more recently. When we encountered the COVID-19 epidemic, we had to make a lot of changes to our product, and we obviously had to work around being able to work remotely with each other and find some happy middle ground project that we could continue working on for the senior design. We did have difficulty integrating our project with Wes originally, but after a bit of time in debugging and time spent with one of their developers, we have been able to bring everything together into a nice package, I think. Our time and data constraints to create an object recognition model was a big one that we were worried about facing because we were undeterminate whether we would have access to Wes trained model or not. The object recognition model specific to the videos that we were utilizing wasn't provided originally, and so it has it's thrown us a little bit for a loop trying to get our models to read out accurately for our input videos. And then the lack of availability of a GPU or any more powerful hardware to run our software has also been another one, especially when it comes to increasing the time proficiency in a lot of these algorithms and functions that are already in place. Some of the lessons that we've learned throughout this is that we should not and cannot depend on other parties to finish core parts of the project. It's really good that we have at least a hand on with these core concepts and core functioning pieces to ensure that they are getting done in a timely manner. There can be difficulties establishing a solid communication between all the parties involved, whether that be between us as a group and West, and then even at different points throughout this semester, I know that we've encountered and overcome difficulties being able to meet as a team. Our project expectations should begin flexible and should become more refined and shapely as we get further along in the project and are nearing a product deadline with it. And then our final one is we got to firsthand experience a lot of the difficulties that come along with building on pre-existing projects. The next steps and kind of future projection that we have for this project and what we would intend or hope would happen next with it would be modifying the scripts to successfully mark all the objects found and not break. Currently ran into some issues where objects being found created us heavy bug reports that we unfortunately didn't have enough timing to get through all of them. Training an object recognition model specific to footage being analyzed. So we would hope that we could get a more highly tuned model and granted, with more videos being put through and more videos for the model to be trained on, it's going to get better with time as it goes. Compiling subsequent frames back into a video as a documentation. So our final product of our production right now is our final directory is a set of images that are marked with the times from which frame it is corresponding to the video. We'd like to see this stitched back together into complete videos for a small clips where we actually have birds or other recognized objects in frames. Optimizing the software to work in real time is another one that we unfortunately didn't get the opportunity to work on. We didn't have a good way to access live feed from any of our cameras to start incorporating that into our process. And then deploying the software into a live surveillance system environment to run, test, and compile log data for us. Throughout this project, our team members, we wore a variety of hats. After we had the COVID-19 outbreak and we had such a major mass restructuring on not only our project alone, but how we work on our project and communicate with one another and are able to get things done, we found that it's best to really have everyone involved with just about every task, whether they were directly involved or whether we were just sharing screens, watching one another work. Having that group mentality of everyone works on everything really helped push our team to hit deadlines, finish projects, and get things up to a functioning point for us. Thank you for listening to the final update of our project, and we'll be hosting a live demo on May 6th where we'll be fielding questions. We're looking forward to seeing you there.